Hi guys, Miss Powell here. Today we're going to talk about solving quadratic systems algebraically. We have 4 basic steps. Step number 1 is to solve one of the equations for a variable. Step number 2, we want to substitute what we find into the other equation. Step number 3, solve for a variable. And step number 4, we want to substitute whatever the variable is equal to into an equation to find the remaining variable. All right, so let's go ahead and look at example 1. Okay, so with example 1, the directions ask us to solve the following algebraically. What we can see here is that we have a quadratic equation and a linear. So according to my directions, the first thing that I want to do is I want to go ahead and solve one of these for a variable. This is going to be the easiest equation to do that with, so I'm going to solve for y is equal to x. Please ignore the dog barking. Step number 2, I want to take that and I want to plug in x for every single y that I see in the top equation here. So here I have x squared is equal to 5x minus, substitute x in for y. Go ahead and combine like terms here so that we can solve for x. So x squared is equal to 4x. Here we want to go ahead and we want to get everything over to one side of the equal sign set equal to 0 because of the fact that we have a square term and a linear term. So carrying this on up here so I don't run out of space, I have x squared minus 4x is equal to 0. Well, we can see here that I have a GCF of x. So I want to factor out x. That leaves me with x minus 4 equal to 0. Set each one of these factors equal to 0, and I have two potential solutions for x. I have x equals 0, and x is equal to positive 4. Okay, so x equals 0 and x equals positive 4. All right, so now at this point, I want to go ahead and step number 3, I want to plug these back into, I guess technically this is step number 4, plug these x values back into one of the equations to get the corresponding y value. So the easiest equation that I can see to do that with is my y minus x is equal to 0. So I'm going to be very clear on what I'm substituting in where in this first example, just so that you guys don't get lost on where these points come from. So I'm going to say when x is equal to 0, y minus 0 is equal to 0. What I get out is y equals 0. So my point here is the point 0, 0. When x is equal to 4, I can plug that in. Y minus 4 is equal to 0. And what I end up seeing is that y is equal to positive 4. Okay, so here my point is 4, 4. Therefore, I have two solutions to this system. The point 0, 0 and the point 4, 4. All right, let's go ahead and look at example number 2. Well, with example number 2, what I can see right off the bat is that I already have one of these equations solved for a variable, right? I have y equals negative x minus 1. So that makes my life a little bit easier in the fact that now I can go straight to plugging in negative x minus 1 in for every y in the above function. So bring down the x squared plus negative x minus 1 squared equals 41. Now, please don't get creative here, right? Negative x minus 1 squared is not negative x squared minus 1, right? We want to go ahead and FOIL that out. So x squared plus negative x minus 1 times negative x minus 1, that's equal to 41. Now we want to go ahead and FOIL this out, and what we get is x squared plus 2x minus 1, plus 1, sorry guys, equals 41. Okay, go ahead and clean this up. We get 2x squared plus 2x. Plus 1 minus 41 gives us minus 40 is equal to 0. So now this is as cleaned up as we can possibly get it before factoring. Now if I'm looking at this and I want to factor, one thing that I notice here is that I have a GCF of 2. So I can actually make these numbers easier to factor by dividing each one of these terms by 2. When I do that, I'm left with x squared plus x minus 20 is equal to 0. And now that's much more reasonable for me to deal with as far as factoring is concerned. So when I break this up into two factors, the two factors that I have are x plus 5, x minus 4. Setting each one of those factors equal to 0 and solving, you get x is equal to negative 5 and x is equal to positive 4. So now I want to figure out what my corresponding y value is. So once again, we're going to take our x values and we're going to plug it back into one of our equations to find the corresponding y. You need to go ahead and plug it back into this linear function because it's the easiest thing to do. So here, if I have y is equal to negative 5, that makes that 5 positive, minus 1, I find out that y is equal to 4. Therefore, one solution is negative 5, positive 4. The next solution, plugging in 4 for x, I get y is equal to negative 4 minus 1, which gives me negative 5. So my other solution is 4, negative 5. And there we are. Those are my two solutions. All right, let's move on and look at example number 3 here. Okay, so with example number 3, I want to go ahead and solve one of these for a variable. So clearly, this is going to be the easiest one to deal with. So I'm going to solve this one for x. So x is equal to 4 minus y. You could have solved for y. It would not have made any difference at all. The first thing that came to my mind was to solve it for x, so that's what I went with. Okay, so that would be your step number 1. Step number 2 is to plug in 4 minus y in for every x value in this function up here. So here I have plugging in 4 minus y in for x, I get 4. Let's take that off. Okay, sorry. There we go. 4 minus y squared is equal to 2y. Now don't forget, 4 minus y squared needs to be FOILed out. So really that's 4 minus y times 4 minus y is equal to 2y. Cleaning this up, we get 16 minus 8y plus y squared is equal to 2y. Cleaning this up further, I get 16 minus 10y plus y squared equals 0. All right, so now this is looking more familiar. However, you can see that this is not in descending order. So before we go to factor this, it's probably going to be easiest if we rewrite this. So when I rewrite this, I have y squared minus 10y plus 16 is equal to 0. All right, so solving this guy right here, we want to find two factors of positive 16 that will add to give us negative 10. So clearly that's negative 8 and negative 2. So y minus 8, y minus 2 is equal to 0. Our two solutions for y are positive 8 and positive 2. All right, so now we have to find the corresponding x value that goes with these y values. So going back to my linear function here, I have x plus 8 is equal to 4. So when y is equal to 8, it's an equal sign, x is actually equal to negative 4. So negative 4, 8 is 1 point. When y is equal to 2, I have x plus 2 is equal to 4. What I get is that x is equal to positive 2. So my other point that I have is 2, 2. So these are my two solutions to the system of equations that we just worked. All right, we have one more example here. It's example 4. Lucky for me with example 4, I already have one of the equations solved for a variable. So I can go ahead and I can plug in y plus 3 in for every x value that I see in this function right here. So I'm going to go ahead and do that. All right, so in for x, I'm going to plug in y plus 3. I'm going to square it, minus 6 times y plus 3, plus y squared, plus 12y equals negative 9. All right, so now we need to go ahead and clean this up. So y plus 3 squared, we want to go ahead and FOIL that, and you end up with y squared plus 6y plus 9. Distribute the negative 6 throughout the y plus 3, and we get negative 6y minus 18. Bring down your plus y squared plus 12y minus 9. Excuse me, equals negative 9. Okay, now we need to go ahead and combine like terms. Y squared and y squared gives me 2y squared. Positive 6y, negative 6y, those cancel one another. They eliminate. Bring down your positive 12y. All right, so I've dealt with my squares. I've dealt with my linears. Now I want to look at my numbers. So here I have negative 18. Negative 18 plus 9 is negative 9. Negative 9 plus 9 actually goes to 0. So equals 0. All right, so now what I can see is that I have a GCF between these two terms of 2y, so I want to factor that out. Remember, my goal here is to solve for y. So if I factor out 2y, I'm left with y plus 6 is equal to 0. Setting each one of these factors equal to 0, I get y is equal to 0 and y is equal to negative 6. All right, so now we need to figure out what our corresponding x values are. So I'm going to change colors here real quick, just so I can differentiate between my problems here. I want to figure out when y is equal to 0, what does x equal? So when y is 0 plus 3 equals x, what I end up finding out is that x is equal to 3. So here, one point or one solution is the point 3, 0. Okay, now when y is equal to negative 6, we want to find out what x equals. So plug in negative 6 for y in our linear function, plus 3 is equal to x. And what I end up seeing is that negative 3 is equal to x. So when x equals negative 3, y is actually equal to negative 6. And these are our two solutions to the system of equations. All right, guys. Hope that you're doing well. Miss seeing you all, and let me know if you have any questions. Thanks. Bye.